Kevin Kurtz. I'm the VP of Engineering for Quadrant Solutions. Let's talk about how we actually refine the elements used in heavy rare earth materials. So we have a section of the periodic table that involves the rare earth magnets. That's the lanthanide series. That's that one that's pulled down out of the table in a lot of the maps. The way that we refine those is usually through a series of acids. So those are mined in a pocket or a giant rock ore called bastanite that contains all these rare earth elements, and they're separated out through a chemical process, usually with an acid that removes different materials as we go. So we can liquefy them in a solution, put in this acid material. It will bond with the different elements and they'll solidify and be able to separate out. That can be done in a large scale, but it is a really messy process, unfortunately. It does create a lot of environmental hazards with these acid materials that are etching through that bastanite material. So there are some cleaner ways we can do that. We can lower the temperature and do this under a magnetic field because they have different paramagnetic properties. We can separate out the solids without having to use as much of the acid material. A lot of different lab tests, but it is very challenging to separate out these materials from the rest of the less rare materials that are involved in this. Because inside this ore, we've got our neodymium, we've got our samarium, our terbium, our dysprosium, the things we need to give the magnets coercivity, but we also have cerium and other things that we don't need that might be in some rare earth materials, praseodymium, that we aren't using in most of our NdFeB materials. So these have to be separated from the ore. And there's a lot more common materials in there. We've got a lot of irons, we've got transition metals inside. We've just got plain silica and dirt that's inside these materials as well. So we have to separate these out and refine these into as close to a pure element as we can so we can throw them in what I call our cake batter, our recipe mixture for the sintered NdFeB. And this can be a difficult process. It's often done in isolation, far away from other people because of the acids and other materials. The mining is also pretty dirty. We have to blast and clean and get to these ores that are only located in several areas. China has a large deposit. The Pacific Northwest of the US has several mines and deposits that we currently don't mine and use, but they have been used in the past. And then they have to be refined down to the rare earth elements that we use in everyday life. We're going to take them and throw them in with purified iron, with boron, do a mixture. We'll throw in some of that dysprosium and terbium in with the neodymium to give the material our coercivity that we require. But if these are not purified, if they're not 100% pure elements that we're using, we're going to get lowered magnetic properties. So they do need to be defined and isolated into pure materials, pure elements that we can get. The good news is we can do this over and over again, so they can be reclaimed in a recyclable manner after the materials have been used. We have a lot of recycled rare earth materials that we use, and these are reclaimed through similar processes.